Hi, hello everybody. So this is the video dealing with section 10.2, arithmetic sequences, and this is the second uh, part dealing with the sum of a arithmetic sequence and the summation notation. Now, so in the previous part, we saw what a sequence was, and specifically a numeric sequence where the common difference was fixed. So that's called a arithmetic sequence. And now in this video, we're interested in adding up the first n terms of a particular sequence. So when we are dealing with the sum of the first n terms, we usually call that a series. So there's a formula for the sum of the first n terms of an arithmetic sequence, and this is the formula. So whatever term that you want to stop at, so let's say, for example, at 7, in this case, n would be 7. So it would be n divided by 2, first term plus last term. Okay? So the sequence would obviously continue, right? So I have A1 all the way up to A7. I'm just interested in adding up these 7, but obviously the sequence continues, right? These are always um, infinite sequences. Okay. Now, sometimes, for example, let's say that you're trying to find the sum of the first 200 terms. Now, it's not very practical to enumerate all of them. Okay. So there is a notation that we normally use called the summation or sigma notation. Okay. The word sigma is the Greek symbol capital S for sum. So if I'm interested in finding the sum of the first n terms, we use this notation that you see right here. I'll make it a little bit bigger. Where we have a variable to denote the index. This is a starting point. We don't have to start at 1. And this is the ending point. And this is the term of the sequence that I'm going to be adding. Okay, so here's a couple of different examples. So let's say, for example, I have this. I'm going to add from the first term to the third of this particular sequence. So wherever I have I replace with the index. So I started 1 square, 2 square, 3 square. And then I just evaluate this. Or I can use the formula. Here's another case. Now I'm starting at 4 and I'm ending at 5. So you're going to replace I with the index, start at 4 plus 1, and 5 plus 1. And then we evaluate that. Okay, obviously, for series that do not start at 1, we cannot use the formula, right? So the formula is only for sequences that start at 1. Okay, and the reason for that is, here's the formula. All right, so let's just go back and take a look at the formula again. This is a formula for the first n terms, meaning we have to start at A1 and we're going to have to end at whatever point we're trying to end at. Okay? All right, so let's see a couple of examples. This is, again, not very difficult, so I doubt anybody's going to have any serious problem with this. I will just write the formula here. All right, so first let you see the formula, and then we can copy down here. And usually, in questions dealing with the summation, something else is going to come up, right? And I am going to have to know how to find the last term of the sequence I'm trying to find the sum of. So then you have to go back to the first part of the video and remember that the formula for the general term of a arithmetic sequence is this. So we kind of have to know that formula as well, okay? Because that information may not be given to us. Okay, so let's put this right here so that we can see while we're doing the problems. So example 4 and 5 are taken from the book. So here's the fourth example. Find the sum of the first 100 terms of the arithmetic sequence. This is the sequence. So I need to find the sum of the first 100, which means the n is 100. So 100 divided by 2. The first one is easy, it's given. But the last one, a sub n or n a 100, is not. So I have to step aside and I have to find a 100 using this formula up here, right? So I know the first term. I know that n is 100. Now I need to find the common difference. Now the common difference is the difference between two adjacent terms, okay? But it's always the current term minus the previous. Okay, so in this case, 3 minus 1, 2. All right, so a 100, and the difference is fixed, right? If I pick any term, the difference of that term minus the previous has to be the same. So 7 minus 5, 2. So 1 plus 99 times 2, 1 plus 198, or 199. So that's my last term. So then I have 50, 1 plus 199, or 50 times 200. And then at this point, you can use a calculator if you want to, or you can, something easy as that, you can do it in your head. So the sum of the first 100 numbers for this particular arithmetic sequence is 10,000. All right, very good. So simple enough. We had to apply both formulas in this particular problem, right? And that's usually the case. Right, so actually, maybe I should put it back. And the sum. Right. In the second example, I have a problem given to me in summation notation form. So I want to find the sum of the first 25 numbers. All right. So I am going to put it in this format. So I know that n is 25. So 25 over 2. Now I need to know the first and the last. Not really given here. So let's take a look. The sequence is 5i minus 9, and we're going to start at 1. So A1 would be 5i minus 9 when I is 1. So that is 5 minus 9, which is negative 4. So this is negative 4. And now I have to find the last one. Now to find the last one, I'm going to use this formula, but I need to know D. Okay? So, and I know D is the common difference, which is a fixed number, which is the difference from the current minus the previous. So I'm going to find A2. So this is 5i minus 9 when I is 2. So this is 10 minus 9, which is 1. Now, the common difference is A2 minus A1. And be very careful, right? 1 minus a minus 4, or 1 plus 4, which is 5. All right. So now I know the common difference. I can find the last term, which is A25. So A25, right? Because I need to find this. So this will be sum, first 25, 25 over 2. The first term I already know is -4. And this is A25. So A25 is A1, according to this formula, which is -4, plus 25 minus 1 times the common difference. A25 minus 4. This is 24 times 5. And then at this point, again, like I said, you can either do it in your head or you can use a calculator. Here's the calculator here. So -4, let me just clear everything. -4 plus 24 times 5, and that is 116. All right, so now that I have a sub n, I go back here. 25 over 2, -4 plus 116. And I can find out what this is. So this is 25 over 2, and this is 116 minus 4 is 112. And you can use a calculator for that, or you can do it in your head again, like I said. So I have 112 divided by 2 times 25. So this is 1400. Okay, so the sum of the first 25 numbers for this sequence that is given in summation notation is 1400. Okay, so let's see the last two examples. They're all the same. Okay, so the problem can be given to you either maybe in a more verbal way, in summation notation, or these two ways, which is the same as before, right? So either in a more verbal notation or maybe summation notation. Okay. So find the sum of the first 50 terms of the sequence, identical to the first case. And the second case, identical to the second case. Okay, so sum of the first 50 terms is S50. So this is 50 over 2. Now I look at the sequence that I am given, the first few terms. Now notice it's important that you read the word arithmetic sequence, otherwise the common difference may not be the same. Okay, so this is A1, -15. And I need to find a sub n. I don't have it here. So for that, I go to the general term formula. A1 plus n. So this is my 50, n minus 1. So it's 49 times the common difference. So what's the common difference? Okay. So current term minus the previous. So 3 minus -3, obviously 6. And this common difference is fixed. So if I pick any other term, it should be the same. So for example, from here to here, current term minus, I'm sorry, -3. Current term minus the -9. So this is -3 plus 9, which is 6. So it has to be fixed. Otherwise, it's not an arithmetic sequence, okay? So we go back to the general formula, A50, A1, n minus 1 times the common difference, which is 6. We go to the calculator for that. So we have negative 15 plus 49 times 6, which is 279. Once I have the last term, I go back to the sum formula, 50 over 2, negative 15 plus 279, and I go to the calculator again for that. So we have 25 times negative 15 plus 279, and we get 6,600. Right? All right, so this is the same as example 4. All right, and the last case given to us in summation notation. Obviously, if you need to stop the video, obviously stop the video. I'm going into space so that the video doesn't last too long. So very short question, find the sum of, and it's given to you in summation notation. Again, remember that in order to use the formula, this one, okay, the summation notation formula, we have to start at 1. Now, a question doesn't have to start at 1, but to use the formula, it must start at 1. Okay? So I need to find S30, right? Because this is the last term. So this will be 30 over 2. So I have to find the first term here, and that is when I equals 1. So this is 5 minus 3, which is 2. Okay, so this is 2 plus 830. All right, so now I have to go back to the general term formula, which is A1 plus 30 minus 1 times the common difference. So now I have to find the common difference. I need to find the next term. Okay, so the next term would be when I is 2. So 5 minus 6, which is obviously negative 1. Okay, so I'm going from 2 to negative 1. So the common difference would be the current term minus the previous. This is negative 1 minus negative 2, obviously negative 3. Okay, the sequence is decreasing. So I go back here. This is my 830. 2 plus 29 times negative 3. And we go to the calculator again. 2 plus 29 times negative 3. We get negative 85. And now that we have the last term, I go back to the summation formula. 30 over 2. A1 is 2 plus the negative 85. So this is 15. 2 positive times the negative is a negative. This is 15. 2 minus 85, negative 83. And this is my S30. So we go to the calculator one more time. 15 times negative 83, negative 1245 is my sum. Okay? So these are typical questions. They won't be any harder than this. They may be given to you, like I said, in summation notation, or they may be given to you in a more verbal way. In either case, you will be required to know the first formula or use the first formula. You don't have to memorize it because A sub n is in the summation formula.